All right, here we go. Uh, let's start yet. The following table gives our year of data, gives year a function of the population of Nunavut. Something went wrong there. Something went wrong. It's anyways, it's a function of the population of Nunavut, and it's just keeping track of it. We have a table here. Maybe you entered it right away and looked at the scatter plot, but remember, we were guaranteed that they were going to tell us what regression we're supposed to perform. And so we know the first column is L1, this is L2. I've already entered that into my calculator. I'm just going to go perform the regression, which I already did as well. I would still say if you turn on plot 1 and you do a zoom 9, then at least it's going to take you to where the lines are. Because if you don't know where the line is going to go, you're in trouble, right? If you can zoom into it and then just adjust your window zooming out, it's easier than finding it. So when you perform the regression, I run it, this is what I get. Okay, so I will answer that somewhere over here. For A, I will just say stat, calc, it's linear regression, not linear, natural log regression. And here we go, negative 55721 plus 54.92 natural log of x. And I wanted to, I was thinking how I can help you with natural logs. For the most part, unless there's a negative, you're thinking there's going to be, if it's an increasing function, it's going to come from the x-axis, it's going to do something like this. Okay? If it's a decreasing function, it's going to come from the x-axis and kind of do something like this and go towards the y-axis. Okay? So those are your two things to look for. In this case, B is positive, so we're expecting something like this to happen, right? It's an increasing, because you got to imagine it does this overall, but for the word problem, we're concerned with this part, not the negative here. Especially because in this case, let's be clear about it, population is X, and the years since 1996 is my Y. Okay, so in that order, because that's how I entered it. And so we have that equation. Good. Let's graph it now. And some of your graphs look like a straight line like this. In general, we want to see this curving, right, at some point. So we'll talk about that. And I know that some of you probably went by these points, which isn't the worst thing that you can do. It's actually a very good way to go about it, but try to have that shape, that general shape. Okay, make a graph of the function up to 50,000. Right, graph checklist. So we're going to do that. For B, I will just show you immediately. I go to X min. Is it a good idea to go negative? We'll try it. And since X is my population, I want 50,000 on there, so I'm going to go 60,000 on my calculator. Y goes negative, that is good. Y max, I probably have to increase it. I'm just going to go 40 or something like that. So it does something like this already. And that's all we have, right, at this moment. I would say it probably is a good idea to go a little further. So let's see here what we get if this is 100 and this is 75,000. Yeah, to see that curving like that. That would be ideal if you could. B, so let's make that graph. And normally the province gives you a grid. So that's nice. So just remember the labeling part. So this would be population. And this would be years since 1996. So that's important to note, that we're going to be able to actually get the year, the exact year, not this is number of years, but we can actually come up with the exact year if they ask us for it. So 50,000, how do I graph this? Okay, I'm going to find my x-intercept for sure. Here, let's go find it. Second trace 5, enter, enter, enter. And so the x-intercept is 25,497.79. It's just a point that I want on that graph. Okay, and that is a good starting point. And I want to go all the way to the 50,000 it says here. So let's see how we make that work. 10,000, 20,000, 30,000, 40,000, 50, 60, 70. Nothing wrong with going above. So 20,000, 40,000, 60,000. Okay, so consistent. And how do I find out how high I have to go here? I figure out at 50,000, so second trace 1, if x is 50,000, I'm at 3698. So I'm going to actually figure that out here. 50,000, 3698. I'll tell you another little secret. I know that we emphasize keystrokes. That's mainly so that if you get it wrong, that we're like, oh, but you knew what you had to do, so we can give you half a mark. If you get it right, like if you do points on the side that you want to use for your graph, there are no keystrokes necessary for this. You can just like make them appear, and we will know what you mean by that. Okay, so this is 25,000. This would be 2030, right? So 25 is right about there. And at 50,000, I'm at 36. So I'm going to go up by tens here. Right, that's probably the safest. 40. So 36 at 50,000, I'm at 36. This is 36, is right about there. And maybe you want one more. I'm going to try one more. Second trace 1. You're okay if you didn't do it, okay? That's fine. As long as it's drawn to scale, you are fine. So that'd be 55.46 at 70,000. There we go. 70 is right here. 55,000 would be, this is 50. 55 is right about there. So you kind of have this happening there. And I will tell you also that these points were not perfect. I don't know if you've seen it on your graph. Once you graphed it, they were a little off. So if you use these points to graph, your graph kind of looks a little wonky, right? Because this is like a modeling scenario. I can tell you this, on the exam, if they give you a table, it's going to be bang on, like it's going to work for you. But in real life, data is never perfect, okay? It is a little off when you try to model it, okay? But the points they give you, they make sure they land right on it. As far as I've seen, that's usually the way it goes. And they wouldn't make a big deal if the points are a little off. If you've used these ones, but what you don't want to do is do like a zigzag thing. Like let's say your points are a little off like this, they would not want to see this, right? So you kind of have to then, you have to be the one that's going to model it and find the line of best fit, okay? So they do not want the turning points there. And also, please don't make this come back down, because then now we're talking parabola perhaps, right? So that can't be either. So you got to make sure you don't give an indication that this is curving back in. So that is what you're looking for. The equation. ln x. And so if you have all of that, so I'll give you this. I'll give you 1 mark for the equation. We will give you 2 marks for the graph. And so I mean like having a scale, having everything labeled, having the points where they belong. C, according to this equation, in what year will the population reach 40,000. And you know that population is always first, so they're basically saying, hey, find this point right here where you know x is 40,000. So this is second trace value, x is equal to 40,000, and y is, I didn't find that yet, I have my keys a little different because I changed it. 2473 is the answer I get, but it does ask in what year. So we go 1996 plus 2473. So that would be 2020.73, but you can't have that, right? Can't have that. So we're going to go approximately 2020 or 2021. You choose. You don't have to do the or. You can just go 2020 or 2021. That is good enough. So I'll give you 1 mark for actually coming up with the 2473, and I'll give you 1 mark for actually coming up with the actual year. Okay? D, according to this equation, how many people are living in Nunavut in 2021? In this case, you have to, you know how we add the number of years to get our year? In this case, you need to subtract both years to find out how many years went by since 1996. So you subtract, and you find out that it's 21 years that have gone by. So in this case, they're asking, what's the population after 21 years? Right? 21 years having elapsed. So you go y2 is equal to 21, second trace, intersect, and you get, I'll do this. Do I have to adjust my window? I don't think so. I think we're good. 21 right there. Just make sure it appears, otherwise it probably won't find it. So x is equal to 37,374. Because it's people, for some reason I used 2017 on my key. So I probably changed it. It does say 2017 here on my key, but I wanted it to be a bit more relevant, so it's 25 it is? 25. It makes sense, yeah, 25. Sorry about that. So what's, that changes everything, right? No problem, no problem. Thank you for letting me know. So that's 40,198, right? And on the exam, feel free to just go 40,198. You don't have to write down the decimal and then the whole number. They're assuming you're rounding to the nearest whole number, so you're fine. Because it's people, we keep it to a whole number. So here, I will, just to make it easier, I will go 1 for subtracting and then another 1 for actually coming up with the right answer and showing the work for that. So 1, 2, 3, 4, 5, 6, 7. 7 marks for this page here. Yeah. Yeah, that's a good question. Because of this, right? Make a graph for up to 50,000. The main reason I put that in there is because if I didn't put that, most of you would have just had a straight line going up, and it. So I just wanted you to know like how far away to go. I wasn't specific enough, so regardless, you get the mark. If they give you a clear indication that at 50,000, the population does not grow anymore, it stops growing, then you would want to stop there. If they're very clear about that, you would want to stop. Yeah, that's a good question. And so how is our domain and range here? Let's just do it just for fun. My domain What's my lowest x value? Yeah, 25, 497, 79. And according to this model, the population just keeps growing. Okay, there's no stop for x on the right side. If you thought it stopped there, then you would say 50,000 is your end, right? And my range, the lowest it ever gets is times 0. And it keeps on going indefinitely. So this is just an additional